Jeffrey, and this is the Passionate About OSS podcast. The purpose of the podcast is to shine a light on the brilliant minds in the OSS and telco industry, to describe a little about their background, but also to share their knowledge, tips, and techniques. Today we'll take a look at identifying a niche or opportunity and building that into an OSS from scratch. I should warn you though that this is going to be a slightly longer episode than normal, but we'll cover a lot of really cool stuff with our guest. Now, today's guest is a CEO and founder of an OSS vendor. He's been in the industry for a little over 20 years and has a strong entrepreneurial streak, but always takes a really hands-on involvement in the building of the product within those companies. The thing that impresses me most about our guest is his crossover points. He can deep dive into the tech. So in IT, he's a developer extraordinaire. In operations, he's had a background in carriers such as Carrier One. Has a deep knowledge of networks, spends a lot of time looking into future tech, such as he's already dabbling in OSS's next launch points, such as VR and AI. He has a deep understanding of the business needs, so his startups have always been really customer-facing. He has an eye for detail, particularly in relation to scale, resilience, and optimization of those factors. But more importantly, he has a really rare focus for user and customer experience in the tools that he builds. He's now been running his own OSS/BSS product company for nearly 10 years. I'm delighted to have him on the call because he's a brilliant innovator, but he's also able to tear apart and help reassemble the many harebrained products and ideas from people like me. So welcome to Jay Fenton.
You're very welcome, Ryan. Nice to chat to you.
So Jay and I first met around about 5 years ago when Jay was starting to make significant inroads in his implementation of Savvy for NBN. And I was just a humble worker working away on a PNI, or Physical Network Inventory project at NBN at the time. But your networking and OSS journey goes back far further than the last 5 years. You worked as a network sysadmin in the late 90s. That must have given you some amazing insights into operating networks.
Oh God, I think it was, there's no better grounding, I think, in OSS systems than cutting your teeth in internet providers back in that kind of era when everything was really just so new and greenfield. You know, we were still trying to figure out how to build both voice and IP networks, the internet obviously being very much in its infancy. At that point, you know, there were no iPhones. I'm not sure when Amazon kicked in or any of those, the websites that we take for granted now. But whatever was around was very rudimentary compared to the kind of UIs and the experiences that we have now.
So in those early stages, you must have been really thrown in the deep end as sysadmin, really looking after the networks yourself. Was it a steep learning curve in making that transition?
Absolutely. I was incredibly lucky. I ended up working for a very small kind of business class ISP down in Brighton in the UK when I was just 18 years old. And that was really a trial by fire. They'd lost their sole sysadmin a few months previous to that. I never did find out the actual story there. He may still be hidden in the data center somewhere.
Or in the woods somewhere.
Or in the woods somewhere. Yeah, well, the systems weren't that bad when I got there. So, but certainly, after a couple of months of not being tended to, somebody needed to come in and shore things up. I was very green. I had, read the Linux Systems Bible, huge thick book that I'd gotten my hands on as a teenager, and joined them really only knowing about the internet on the periphery. I'd spent, a few years being intimately familiar with, BBS systems, if you remember those, calling all over the world using my modem, much to the dismay of my mother and the phone bills that she would receive. But yeah, really the internet, I only knew in theory. I dabbled with Linux and I'd actually built a little internet cafe when I was about 16 years old, turned a video shop into an internet cafe, as you did in those days.
Of course.
I learned a lot from that about networks and IP and, at the time, PPP and SLIP and dial-up and all of that and building gateways. But none of that truly prepares you for going to work for an actual internet provider. That was my dream job. That was where ultimately I wanted to end up. And I was very lucky in being able to tick that box very early in life, really. But it came with a set of, I had to deliver. I was literally the sole systems admin for this small ISP. I think they had about 2,000 business class users on ISDN and leased lines. And, if it broke, it was either my fault or I was going to be the one fixing it anyway. Nothing really prepares you for a career in telecoms like that. It was amazing, and I count my blessings for having that experience. I moved quickly from there. I think I spent maybe a year and a half there, and then was headhunted by a company called Carrier One, which was a pan-European carrier based out of London, but serving had a European-wide voice and IP network, SDH network, in various cities around Europe. That was also really illuminating. I had always been really interested in voice networks. I was very lucky. And I think the statute of limitations has probably expired by now. So I was very lucky to catch the tail end of the kind of phone phreaking and, hacking of voice networks kind of movement. I actually had a little pop quiz for you prepared here. I have a little device, and I'm going to... I wonder if you know what that tone is, Ryan.
That wouldn't be the old Captain Crunch whistle that you managed to get hold of somehow. Did they ever make their way over into Britain?
I am very, very impressed. I'm very impressed.
26,000 hertz, 2,600 hertz.
2,600 hertz. Yes,
thereabouts.
Very good. That was the C's tone. I don't think the Captain Crunch whistle itself ever made its way to the UK, but certainly my Amiga computer generated many of those tones over the year when I was a miscreant teenage youth. Yeah, so I think I learnt about voice networks, again, kind of in theory and blindly stumbling around voice networks when I was very young, way before I even knew of the existence of IP, I would say. When I joined Carrier One, it was just incredible to me. I was there ostensibly, on the IP side. I was senior systems engineer, building out their network management systems, working on things like HP OpenView, which became Network Node Manager, Netcool, really, very much in the SNMP side of the world, which is something that ended up being the foundation of a few decades of my life, really, in terms of things that I went on to create off of the back of that experience. I was always in awe of the voice guys. That to me, it was one of those, oh my God, I'm actually here. I'm sat next to the guys who run those voice networks, which I've been roaming around for a few years. Actually, I can tell you a little story on that, if you would like to hear it.
Yeah.
So when I say exploring the phone network, so what you used to do, and this was, when would this have been? This might have been like maybe 1994, something like that. I think I was 14, 15, something like that. You could call an out dial in the UK, and I still remember the phone number. It was 0800 800 971. And you could connect to, I won't name the country, but you could connect to one of these calling card services, and you could play your 2600 hertz tone, and you could seize the line. And so the operator would come onto the line, and she'd be, Salam alaikum, and then you would seize the line, and then you could essentially command and control the phone network from there, because all of the signaling was done in band. So if you knew the frequencies of the MF tones, multi-frequency tones, which is slightly different tones to DTMF, which is the, when you press 1, 2, 3 on your keypad, you could actually route calls yourself around the world. You could connect exchange to exchange. You literally were talking directly to the exchange equipment. So, I spent a lot of time, and we'll come on to this later when we talk about probably party lines. But I had a
also revenue assurance, perhaps.
Yes, quite possibly. I spent a long time. Every evening when I had gone to bed, I would call my friend, and we'd do a 3-way call to this 0800 number. 0800 is a free call in the UK. And then we'd seize the line, and because we were on a conference call, effectively, we could both listen in, and we could both play tones down the line to experiment. And we were learning all of this from bulletin board systems, and the various text files you would find on there. But here's the interesting bit: a few months, go by where we're doing this, and every night we are exploring. Every night we're dialing this 0800 number many, many times. And just having so much fun. I'm going to bed at crazy hours of the morning. Nothing changes really. I'm still like that these days.
You're using the same whistle?
No, well, so a computer program that would generate the same tones.
Yes. I'm just kidding.
Yeah, I actually, so this little whistle, I actually thought that it was an original Captain Crunch whistle, which was a little toy that came in the Captain Crunch cereal boxes in the US, which just happened to generate a 2600 hertz tone. The guy called Captain Crunch is a famous phreaker phone hacker who figured this out because he was very excited one day that he got this in his cereal box, and he played it down the phone to his friend, and the line went dead. And he did it many, many times, and it's like, well, the line goes dead every time we do this. And he was a curious soul, and eventually figured out that this was kind of your gateway drug into the phone system. It
also proved to be Wozniak and Jobs' gateway into the phone system that helped fund Apple.
Very much. So one of Wozniak and Steve Jobs' first collaborations was to build what is called a blue box, which is a little standalone device that can generate exactly those tones. That obviously more advanced than just a whistle. And I'm exploring the phone network with my friend, and a couple of months go by, and I'm with my mother one day, and we go into town, and I need to go to the BT shop, British Telecom shop in the UK, to do something, with the account. I don't know. I'm a kid. I know nothing. Or did I? So we go into the phone shop, and the lady behind the counter is like, "Oh, we'll just print off your bill." Now, the bill that you receive through the post is obviously not the same as the internal, and obviously I'd never heard this term before, CDRs, that the telcos have on the back end. And the woman comes back with, do you remember the green and white kind of folded paper that used to run through the dot matrix printers?
Yeah,
she came back with like a ream of paper, which was our internal bill. And of course, it's filled with 0800 numbers. And the lady behind the counter, obviously, probably not a technical bone in her body. Oh, there must be some mistake. There's some system error or something. Turn white.
The same color, the same grain.
Yeah, exactly. So I didn't get in trouble for that. I feigned ignorance until many, many years later when I finally confessed to my mother what that was all about, and she couldn't believe it. But that was my first foray kind of into phone networks, ultimately into IP networks. And, sitting next to the voice guys who were running those same networks, it was just incredible. And, listening to them, assessing call quality, and having the hunt groups where they would... They'd roam from call to call, just listening in passively for call quality. They'd spend maybe 15 seconds listening into just anybody's phone call. Yeah, it was amazing.
Wow. And so by the time that had happened, had those guys figured out tools, effectively the primitive revenue assurance tools? Were they actually on the lookout for
none of that existed? I mean, yeah, absolutely not. I mean, on the IP side, I built out their usage-based billing solutions. There was no even perception, and it was probably a rounding error, the actual fraud that was going on, and not one that the telcos would bear anyway, because as we ultimately found out, they were just bit pipes, right?
And what other tools were they using back then at Carrier One? So you talked a little bit about Netcall, you talked a little bit about Network Node Manager. Were there any other tools? Were you developing your own at the time too?
Yeah, I mean, I was developing all sorts of things, both in C and Perl at the time. I think most of the telco networks, it's probably fading now, but a lot of those telco networks were glued together by, Perl scripts and things like that. Other tools. So when I came in, they already had deployed Network Node Manager, and that had been set up by Capgemini, I think it was. But there were some up-and-comers in the OSS space, a company called Riversoft, founded by Phil T., who was one of the original co-founders of Micromuse, which was Netcool. And Riversoft was just incredible in terms of the leaps that it had taken versus the current state of the art at the time. It was all about autonomous discovery of layer 2 and layer 3 networks, generally using SNMP, so walking the MIBs of all of those devices, stitching together this coherent topology in, really a graph database before we really even had graph databases. And then using that to reason about and to visualize the network and to, debug and diagnose issues and understand, to try and answer that, that holy grail of OSS, which has always been root cause analysis. What has gone wrong? Just show me. Really, there's no reason that a system that has all of the knowledge of the topology of the network and the performance metrics and alarms can't bubble up to you the root cause of the issue. And we were trying to get to that in the mid 90s, and that really was the precursor to, I think, a lot of the things we're seeing now in AI/machine learning in the telco sphere. Some companies, kind of trailblazing that. Obviously, companies like Google and Facebook they don't manage their networks in the way that we manage our networks in the telco sphere. It's a lot of it is automated. They have very little headcount in terms of operations, and it's I wish they would share more with us how they do that, and I wish they would open more of that up, but obviously it's a secret sauce and very valuable to them to keep on top of that. But we'll get there eventually.
Yeah, absolutely. And when you were at Riversoft, you were part of the executive product board, so you were really steering their next-gen NMS. But I do vaguely recall you mentioning how some of the innovations that were brewing there at Riversoft never really got to see the light of day back then, but would be invaluable now, and perhaps are even starting to appear all these years later. Are you able to talk about some of what you worked on? And that was back around the turn of the century.
Oh, I think Executive Product Board was a bit of a lofty title, probably given to potential customers who they wanted to, get on board. But it was certainly nice to have very early in my career, to be able to give guidance really on this is where we see network management systems going. This is where we see OSS systems going. A lot of it was, I can really, put it in a nutshell. It was what I mentioned before, which was building this graph of all the things, this very intricate topology and rendering of the network at large, all the way down to your interfaces, your SFPs, all of the interconnections, and then overlaying that with all of the performance data. At the time, there was nothing that was doing that. That was truly groundbreaking.
And the underpinning technology able to keep up with that. So I guess we've now got the graph databases that are highly performant. We've got much better compute than we had back then, much better databases and storage than we had back then. So was that more of an ambition or something that was actually achievable? Had you actually built it out?
You have to remember that this was this was right at the beginning of the Cambrian explosion that was the internet. There was incredible amounts of money available. There was no expense spared in terms of hardware. This was the era of Sun Microsystems and Starfires, E10000s, FT1800s. Systems that, whilst by today's standards, obviously much, much smaller in terms of their computability, were still at the time groundbreaking. And I think, the networks themselves in terms of number of devices were much smaller and simpler than they are now. So yes, I think the headroom was certainly there from a compute point of view and processing point of view. I think, ultimately Riversoft was a victim of the, .com crash. Fire sold to Micromuse, Fire sold to IBM, ultimately landed there. I wouldn't say that there's anything today that really ticks the box in terms of the original vision of what we were trying to build back then. It was a lofty goal. We still haven't solved root cause analysis in telecoms, but I think the first step to that, of course, is to gather the data. You need to construct this model of the network, and you need to bring in all of the performance counters. Something which has always been, very close to my heart in terms of my passion. You're passionate about OSS. Mine is slightly more granular than that. I'm passionate about collecting all of that information at scale and making it easy to bring in that performance data, make it easy to render that topology and understand how things are connected together. That's kind of been my focus for the last 10, 20 years, really, and both in terms of what I built at Savvy and the precursors to that, all the way back to those seeds that were set in place at Riversoft and Carrier One.
And when we look back at it, I guess the fundamental use cases haven't really changed that much in the last 20 years. It's just the way we are tackling them. Do you agree with that statement?
Absolutely. Although I'd caveat it by saying that the networks we have now are just so much more complex. And it's not just networks. It is, virtualized, NFVs. It's the actual stack of dependencies on your service operating as you want it to is so much more complex, so much more dynamic, much tighter latency constraints, much less forgiving in terms of outages, because we all rely on it every day. And there's multi-trillion-dollar industries built off of the back of this. It's interesting. I think that this current shift towards software-defined everything is, in some ways, it's a step backwards, because we're actually making the problem even worse for ourselves by adding all of this, these more complicated layers, these more complex fault domains, when we weren't even doing a good job before, when it was all hardware-based.
And when it was all nailed up, like back in the SDH world that was the turn of the century.
Yeah, absolutely.
And how about the tools? We're already seeing the opportunities to innovate in and amongst the tools that were available back then, and maybe even seeing as far forward as the tools that you've now gone on to develop with Savvy. I guess it's hard to answer that question, what you were thinking of 20 years ago, but I'd love to hear your thoughts. Did you see that predicted?
Actually, I don't think that's hard to answer at all. Really, I'm doing the same job, now that I was doing 15, 20 years ago, at a different scale, of course, because of all the aforementioned reasons. But we now have the ability to both model, collect, process massive amounts of information on the back end, but we also have a commensurate amount of ability to process on the front end as well. And that was always kind of to me, the Achilles heel of the approach, which was, for the last, say, 20 years, it's been about gather all that information, put it in the back end, and then visualize it to the user. And the trouble was that until relatively recently, probably in the last 5 years, maybe not even that long, we didn't have the front end performance in order to be able to visualize a topology that complex. My original thesis was always that you would, if you could just get all of that data in one place, if you could bubble that up to the human operator, and give him that single pane of glass, or a single glass of pain, as some people call it, whereas all of the information is at his fingertips and he can understand what's going on. In security, in cyber, we talk about the security posture of the network, or security posture of the service. Am I wide open? Is my system being attacked, etc.? I'd like to see in OSS start talking about the network health posture. When I go and look at this area of the network, which, I have a number of tickets open I know there's a fault in there. I want to know the health posture of everything in the periphery of that. I want to know, did Bob log into that device 24 hours ago and now there's a sea of red on the screen? And that's, a lot of what I've been trying to build with Savvy is we've absolutely solved the collection of data at scale and the modeling of that data. The front end problem of that has, it's a UX problem of how do you bring all of that data together in a way that's readily understandable, despite its inherent complexity, cutting through all of those layers, being able to scrub back and forth in time and see what was happening in the lead up to a particular event, and also project into the future of saying, okay, so this is a problem now. When does it become a critical issue for us? I think building those coherent user interfaces where we can do that is really interesting. That's been kind of my passion project for the last 20 years. But it's interesting because now we're moving into a more AI/ML view of the world where actually we don't want to have the headcount of operators looking at those interfaces. We want to algorithmically have the system just deal with it all for us and, automatically remediate issues, figure out what's going wrong, do that root cause analysis. And I just feel like we're not there yet. And also I feel we're a little bit too enthusiastic about the machine learning approaches. There are countless projects where perhaps even you've done a proof of concept and you've brought a particular vendor in and you've fed your real world production data into that system and it really has. Oh my God, it's bubbled up. The outages that you have, the reasons for them, it can kick off scripts to auto remediate. But as soon as you put that into production, it never works properly.
Oh, the baseline is all constantly changing.
Garbage in, garbage out problem. And the trouble is we never went back and solved the inventory issue, the data quality of all of those various layers of inventory information is awful at any telco in the world because none of them are simple these days, right? Whether you pick fixed line, whether you pick mobile, it's like this there's all these rocks that nobody wants you to look under. Nobody wants you to actually show them how bad, qualitatively and quantitatively their inventory data is. But we do have the tools now to be able to do that. We are the only industry in the world that has a sub-industry called revenue assurance because we're so bad at inventory data. We're leaking and hemorrhaging cash, usually a rounding error because historically telcos have made so much cash. That's not going to go on forever. I think, there needs to be a lot of attention paid to the data quality and in healing those inventory systems, healing the performance systems, because it's not just inventory. Of course, performance systems, they spit out crazy performance data sometimes, which can completely skew your, finely tuned ML models. And the trouble is, because these resulting models become black boxes, you can't reason about what went wrong when it does go wrong. So whilst my original thesis was to build, to have humans at the helm driving this, you have to remember back when I was originally starting out on this journey, we weren't talking about AI, we weren't talking about machine learning. It was just not a thing. I mean, it existed, but I'm not sure when the AI winter was, but we were probably going through it at that point. Certainly, it never crossed paths with telco in those days. But it has
I guess
now.
That was a fundamental back then too. We were building systems for an operations team to manage the network, where the hyperscalers have shown us that there's a different way forward now, and it's to design systems for machines to process a large amount with very, very thin layer of staff to support.
But the point I was going to make was that because if we take this algorithmic approach, it's all well and good, but we do need to still have those scalable interfaces for us to be able to understand what those algorithms are doing. It's not enough to just have a black box. These are literally critical services for many people. You're running your voice lines over voice over IP these days. It's not just about, grandma can't get to Facebook. It's you can't you can't call 911 anymore. You can't call 000.
Grandma's emergency alert system is underpinned by it.
Exactly. And we used to have this thing in telco when I was growing up, which was dial tone reliability. When you picked up the phone, it was always there for you. We baked that into the fundamentals of, what we were building with the PSTN. And that was always much more difficult, obviously, to do in an IP world. And I think, back then we never considered it was going to become such a mission critical service. But we need to be very careful when we are innovating in telco, when we're innovating in OSS, that we don't make the problem worse. That we don't cause outages because we have, put some firewall or router, which was an NFV, on some virtual machine, and suddenly the latency's gone through the roof, and that's affecting somebody's 000 call. We are not really at that stage of maturity yet to deliver those kind of services over that kind of infrastructure. We have a lot more learnings left to do. And it scares me in a way that we're really jumping on this virtualization bandwagon. Ostensibly, it's to reduce cost. And I just don't think that that's going to be the case. I mean, would you say that there's other kind of axes of innovation that they want there? That we talk about, like, you can have more dynamic services and customers can spin up their own firewalls and their own this and that on this virtualized infrastructure. But we've been able to do that for a long time on hardware. I worked on boxes 15 years ago, Cosine IPSX devices, which were like a virtual router. You could have virtual routers inside of that big hardware box. And, that was a really impressive and innovative device at the time. I worry that we're just, we're over egging the pudding, in terms of trying to virtualize all the things so quickly.
Yeah, we definitely already had a really, really complex stack, and we've just added some extra layers onto it. So I can see the value and the intent, but I can also see the root cause challenge becoming more difficult. So I guess after the Riversoft days, you then spent the early to mid 2000s with a real shift away from telco. But interestingly enough, when I look at some of the things like video streaming, mission critical web infra, web apps replacing thick clients, international payments, surely these things that you stepped away from have proved invaluable now that you've come back to telco in a later phase of your career.
I think, again, I was very lucky to get exposed to many different industries early on. I did a lot of, I've touched lots of different industries out there, and all of that has helped in guiding what I saw as us doing in the OSS space. Particularly things like UX and, creating these fluid workflows that that can be used by mere mortals, creating simple interfaces that can be used for complex diagnostics all the way down to a non-technical user just looking for just mining some data to get an answer from it. I think that cross-pollination from multiple industries and your background also lends itself to the same thing. Having that, having those insights from other industries that most people in telco would not be exposed to. I was working on Salesforce platforms before anybody in telco had even mentioned Salesforce. And these days, look how many operators have migrated to that as a central nexus of a lot of their customer-oriented data. And they are still scratching the surface of it because they actually don't know what it's capable of. I built some pretty radical embedded applications inside of Salesforce in the finance domain that we don't have in telco yet. It's one of the things I've always thought, maybe I should go back and focus on that, bringing your network telemetry and these, what we typically think of as an OSS system, bringing that into your Salesforce UI, for example, would be very powerful. Again, it's about building I don't want to say single pane of glass because it's kind of a dirty word in OSS because nobody ever delivers on it. But we actually do have all of the fundamentals that we need. It was only last week somebody somebody that we both know based out of Japan, said to me, why do we have to create these interfaces and all these these UIs in all these different systems to do reporting and things? Can't we, is there one system that we can build this stuff in? And there really isn't. You see a lot of companies have gone, and actually it's the same person I'm going to mention, that they've gone and deployed things like Elastic, for example, and they've really centralized and doubled down on open source. Everything must be open source all the things, from the database all the way up through to your visualization layers and collection layers and everything, and they've bet the house on Elastic. And for example, not the only one, but I call them out because they've been in the news recently, and because this person I allude to was also using that, and they're using Kibana, and building out their dashboards and reports in that, and it's easy. Kibana's quite a nice interface for building that kind of thing. I'm kind of worried that telco in general has bet the house on open source, and yet we've seen moves from Elastic, for example, in the past 2 weeks, where they've suddenly pulled the rug out from everyone and changed open source license. I mean, not even changed to another open source license. Ostensibly, they've gone from open source to proprietary. And, this proprietary license, it's supposed to be there to prevent the Googles, the AWSs of the world from, and quite rightly so, taking that open source project and making money from it without Elastic getting a cut of it. And that's fine, but what's kind of been forgotten is that telcos are actually not too dissimilar to your AWS and Googles. And if you wanted to take that Kibana interface that you had, that you built on Elastic, and offer that out to your customers now, you can't do that anymore because of the license change. And I think that's an interesting inflection point in open source, where people are going to start asking questions about, maybe we shouldn't have gone so gung-ho into thinking that open source was this nirvana of free technology out there, right? That we could just cherry pick from and build our mission critical systems from. Because, I mean, as many know, you generally can't just use the open source. You have to go and purchase a proprietary license for the various add-ons and things in order to add authentication, security, various bits and pieces to that open source componentry. But you're now finding that you've stymied your business by betting the house on that, when actually, if you'd gone with a proprietary provider from the outset, and it wouldn't even have been more expensive, right? Because ultimately, there is a cost to open source. It's not just in the licensing of the proprietary product, which is often a lot cheaper than a typical off-the-shelf vendor, but you've also got the headcount that you need in order to manage this Rube Goldberg machine of these, dozens of different open source systems that you have to connect together in order to build an actual solution from that. I've been working with a company called KX, which has a parent company, First Derivatives. They're huge in the finance domain, household name level in terms of their technology, running investment banks and so on and so forth. And their technology is amazing. In some ways, I wish I'd never found it, because it spoiled me in terms of finding something that was so performant, so really extracting the most out of the hardware, and just is such an obviously great fit for telco, because you end up with this homogeneous technology that you can build solutions out of. It's not just a database, it's an application server, it's your ability to communicate between components, it's all the things that we try to build with open source, bringing together these multiple completely different components and trying to get them to interoperate. And we need enormous headcount in order to do that. What I loved about KX's approach was that it was, it was this simple technology that you could concentrate all of these solutions onto, that removed a lot of the complexity from the resulting solutions. The Achilles heel is that it's perceived as proprietary and perceived as more expensive than your open source alternative. And it's very hard to get telcos to realize that what they're buying into with open source is not without risk, is not without cost, both CapEx and OpEx. And, telcos have historically not been very good at software development. And you cannot deploy open source solutions without software development. Even if we're just talking about the glue that, binds everything together, you end up being a software development house. And you end up with all of the pain of doing that, in terms of managing large, complex, dependency-riddled software projects and delivering them on time. And, you're constantly kind of fighting against the grain. I'm not saying the off-the-shelf vendors out there that we're all used to in the telco domain, I'm not saying they're perfect by a long shot. They absolutely are not. We've all, gone up against the various bugs and, feature requests on roadmaps that never materialize. We have all been burnt from that over the last few decades. And I think that's probably one of the reasons that open source was so attractive. But it should have come with some huge warning signs, I think, that we really haven't paid attention to. And I think it will start to bite us as time goes on. I'm a huge proponent of open source, by the way, but it has to be approached in the right way. And I think the way that we do it in telco is a little bit, it is just slightly naive. We're not very, because we're also under these intense time pressures in telco. I'm sure you've seen, every project that you go into, it's now, we need to, we're racing to deliver it. We don't have the time to take a step back and actually do the due diligence on these projects and say, well, what are the gaps on this open source project, this open source solution? Have we performance tested it? Have we tested it for fault tolerance, for high availability? What are the gotchas? And it's also very difficult to actually find other companies who are using that open source software who are vocal about their real world experiences with it, because in a way it's showing, we certainly in telco don't like showing our, airing our dirty laundry. We don't like going, we didn't make a good choice on this particular technology that we chose. We just don't do that. And because we don't share, and if you compare telco to a Netflix, or a Facebook or a Google, they're very open. I'm not saying they, talk negatively about technologies, but they're very open about what they've built and how they've built it. And we don't have that same level of sharing in telco. We just culturally don't have it. And I think there's this impedance mismatch in embracing open source in telco versus the real world kind of knowledge of, well, how's it gone for others? And we also don't collaborate enough in telco on these resulting solutions, because there's this fear that, or I believe because of this fear that we're building something that's a special snowflake, and we're so special because we're this huge telco that we must obviously be doing things better than everybody else, and as a result we don't share quite so readily. It happens sometimes, there's telco management forums, TMF, venues like this where some behind the scenes stuff happens, but it's not to the level, it's not to the public level that you see in other industries, and in other internet companies.
Yeah, and I guess we're seeing that a little bit with ONAP as the first signs of some of the carriers really trying to collaborate on an open source project, bringing that into LFN, trying to get other major parties with major software teams to try and contribute to it. But I wonder about, it's definitely got some strengths, but I also wonder about it's still ultimately a monolith, and are we, I guess the pendulum swings between monolith to where we are now with microservices, and I'm sure it will swing back over time to the more monolithic.
I think it's the worst kind of open source project. It's funny you bring up ONAP, and I'll probably take some flack for this, I would imagine, and upset a few people. But if you go and look at the wiki and the minutes from the ONAP meetings, it's you can't compare it to any of the successful open source projects out there. I'm not saying ONAP is not fit for purpose. I'm not saying it doesn't work. Telcos never admit when they've made a bad decision, so they will force it through sheer, force of will to work. But will it work well? Usually not. I think, again, it's an education thing. We don't actually, in the telco industry, we don't study those successful open source projects. We actually approach them in the same way we have always approached telco projects, with the same culture, with the same methodology. We've never been very good at the agile side of things. We're just not. I think perhaps it's down to companies like maybe TMF in educating us and themselves learning more about open source and bringing that, just force feeding the telco industry to say, look, this is how you do it. This is the prescribed way that works outside of telco, that can provide that knowledge share to people in telco. Because I think we just don't approach open source with the right. There should be just a sea of open source contributions from telco. We cannot take things like I'm really I'm picking on ONAP at this point, but there are many telco open source projects that are not run and do not have the same output as other successful open source projects outside of telco. And we really need to take a step back and spend the time to educate ourselves as to how well, what is it that makes an open source project work really well? What are the methodologies that they use? And yeah, I think we need a slight course correction in terms of how we approach them.
So you spent a little bit of time out in the 2000s working with a number of different companies, but then in 2010 you were dragged back into telco through the Telstra International project. That proved to be quite pivotal in terms of your next career steps. Can you tell us a little bit about what happened at Telstra and what came next?
Yeah, so that was the genesis of Savvy, which is the company I still run to this day. So Savvy is about 10 or 11 years old now, and I've kind of I've already given the background on that. Really, it was about delivering on that thesis of collecting all of the things at scale and building ultimately these interface technologies where we could actually readily understand the posture of the network by various dimensions. The project at Telstra was originally around reporting on MetroNIDs at the time. So these were the CDN MetroNIDs, the little inline devices that you would put all around the network. And they had the ability to do active testing, ping testing, layer 2 testing. I believe they had the ability to do NetFlow, although I don't think I ever took a NetFlow feed from them. Although something I'm very interested in these days. And it was about taking the reporting data from all of those and being able to, marrying that with the inventory systems, build this living topology of what was happening in the network. The problem that I think a lot of telcos have had is often, particularly where it's not a software catalog kind of product delivery model, but where you used to have all these special snowflakes of solutions that you would deliver to the customer. Every customer was slightly different. They all had their nuances. It was very difficult when that customer would call the service desk to, and said, "Oh, there's a line of red on the portal. What's gone wrong?" It was very difficult for the service desk to actually know what they'd sold the customer in the first place, and to be able to guide. It was kind of the blind leading the blind. And I always thought that this was a bit crazy.
And data governance was obviously somewhat of an issue if basically the changes that had been made hadn't been articulated back into the management systems within data.
Absolutely. I mean, I know firsthand there's many telcos even today where the encoding of the service is just all baked by hand, by text into the IF Descro, the interface description on the network interface, by the engineer who deploys it. What could go wrong? Yes, again, still a problem that we really haven't done very well at solving, I would say. I'm sure some operators do better than others. Maybe in this kind of SDN, NFV, software-defined kind of own-app style world where we're deploying from software catalogs, it will become much more cookie cutter and less snowflakes. I think, these days it's not as much of a problem, but certainly, 10 years ago, it was. And I wanted to build a system that could model and collect all of the performance analytics and build out this living topology, visualizing it through a web browser, which obviously, 10 years ago they were not in their infancy, but oh my God, what you can do in the browser now is incredible. You can play full kind of 3D games in a browser now at 60 frames a second, and we use some of those technologies at Savvy to power extremely scalable geospatial visualizations and logical topologies. It's quite incredible. I think there's kind of three pillars of the problem there. First is the collection of the data at scale. That's always been an issue. I don't know why it is really, but we've never paid too much attention to gathering the amount of data that we need to from these networks at large. We're talking about networks that have tens of thousands, hundreds of thousands of devices, each bearing, multitude of physical interfaces, and then having many, many virtual interfaces on top of that. It's a lot of things to monitor. And historically, we've used SNMP for that, as you know. And SNMP was never really designed. Well, it's not that it wasn't designed as a scalable protocol. I saw a comment the other day, I won't mention who it was from, but they were saying, SNMP is slow because it was all implemented on CPU and things. But, and this is versus the new hotness, which is kind of streaming telemetry and these pub-sub kind of mechanisms. But it's not actually true. The nice thing about SNMP was that it was tree-based. And so, yes, there would be elements of that tree that were expensive to poll, but typically they weren't the parts of the tree that you needed to poll very regularly, and those would be implemented on CPU. But things like interface counters, they would come directly from the hardware counters off of the ASICs. It was very, very fast path kind of mechanism to pull that data out. The issue was always at the other end, because SNMP is a polling kind of infrastructure. So you have to go to the device and say, please give me the counters right now for these 5 interfaces. And it will give you 5 counters and feed those back to you. And then 5 minutes, 10 minutes, 15 minutes later, you would go and do the same thing. There are now more modern ways. Well, I say there are more modern ways of doing it. There are modern ways of doing it, which is things like streaming telemetry and these pub-sub mechanisms. But you often see them only implemented on the high-end, kind of top class devices from the major vendors, because of course they don't want to provide that to all the boxes you bought last year. They want you to buy the boxes this year. So, you still have to use SNMP if you've got those boxes, but you can get streaming telemetry if you buy our new boxes. Please sign here, and it is definitely better. The streaming telemetry side of things is quite well designed. You have this kind of pub-sub ability to observe these trees of data. I'm not sure really what we've improved over the SNMP view of the world. One of the big issues with streaming telemetry is that it's a very not just bifurcated, trifurcated community, because there's multiple competing standards for this that, still kind of 5-10 years later, they've not settled on one or the other. Juniper's got theirs, Cisco's got another one. And it's the same problem yet again, right? So the problem with SNMP was that in order to go and collect from these myriad devices in your network, you needed to have the system, your collector apparatus, go to the device and request things. Now, in a large network, that's a lot for that collector to do. And the trouble is, the technologies that we use to build those SNMP collectors were built yesteryear. They were built back in the early 90s, kind of 1992, kind of maybe around there. Open source libraries, NetSNMP and things like that, they were not built for performance. They certainly weren't built for the scale of network that we have these days.
And the need for speed, I guess, too.
And the need for speed. Speed wasn't much of an issue then, because you didn't have that many interfaces in your network. So you could get around it all in, the 30 minutes polling that you'd decided to use, because you didn't have the compute capacity, you didn't have the storage capacity to do 1 minute polling, to do 1 second polling. You just, so it was immaterial.
And we weren't trying to do algorithmic recalls or anything like that back then
Correct.
as well.
Yeah, exactly. Networks were smaller, they were more manageable. As networks got more and more complex, and as we added more and more interfaces, more and more layers of abstraction and virtualization and logical circuits and so on and so forth, and many more metrics as well. I think in an earlier talk I did on the Alcatel boxes, there's 26,000 counters for a single interface available. Across the box at large. So it's a lot of things you can poll, and of course we don't look at any of that. I don't know why they spent all the time engineering all of that in. It was wasted, because ultimately we all collect the same thing. We collect in and out octets, we collect disk cards, we collect but we do that, I think, because all of these SNMP collection systems that were built yesteryear, even the modern SNMP collection systems, they weren't built for performance, and they're all built on the same foundations from the early 90s. And so they inherit the performance constraints of that. And so in order to collect a massive network, and in order to collect it at a high cadence, where you want to do 1 minute polling, 1 second polling, you need an enormous amount of infrastructure on the collection side to go out and do that.
That introduces the challenge of race conditions and reconcile across resilient collectors as well. But I assume that with what you're building, that you have a much smaller number of collectors now.
So we actually one of the things I'm very proud of us creating / inventing at Savvy was a next generation collector. Which is going on now to do other protocols, NetFlow and such like IoT protocols, CoAP, MQTT-SN. But for SNMP, because it is actually a complex protocol in and of itself, we started from scratch to build something that truly was a modern collection system. So, an extremely large network here in Australia is monitored via SNMP. Using a 3 CPU core virtual machine on 5 minute polling, an enormous torrent of data coming from that system. We can do that because we truly engineered it from the outset to extract the best performance it could from the system. And we wrote our own SNMP stack, we wrote our own, we directly control the network card, instead of the Linux kernel doing all of that for you. It's complex to approach these things, but the performance that it gives you is astounding. And from that performance comes simplicity of the overall solution, because you can just have one box monitoring everything, obviously 2 boxes for resilience. And we're going to go on to do more and more of those kind of protocols, because that distillation of being able to take what you would normally deploy hundreds of servers in your data center to monitor your network at the cadence that you want to monitor it, you can instead do on 1 or 2 boxes. And I think that's a game changer. I talked about kind of garbage in and garbage out before. If you're monitoring an interface on a 15-minute polling schedule, or if you're waiting 45 minutes plus before, and I say 45 minutes because I know for many mobile networks that is the minimum that it takes for events and alerts to bubble back to their systems. If you're waiting that long to see those insights, and if when you come to look at those insights, it's at a 15-minute granularity instead of 1 minute or 1 second, there's no need
blended to averaging.
You can't extract the value from that data. And if you cannot teach, by extension, you cannot teach a machine learning algorithm off of the back of that very coarse data to react appropriately. And I'm not just talking about performance counters. I'm also talking about all of your SNMP traps and your alerts, your syslog, your NetFlow data. I believe that we should be bringing that all into something that is extremely performant. We need to remove the overheads from collecting that data, because only then can we really extract the value from it, if we can get it at that high cadence, get it reliably. So,
Well, the only way you can really close the loop, it's pointless closing a loop that's an hour long.
well, exactly. I mean, if we're just talking about interface statistics, if you're under a DDoS attack and you're looking at an interface on a 15-minute granularity, well, good luck. You have no chance. So we went out and built. We invested a lot in building a next generation collector that can do 10 million requests per second, SNMP requests per second on a 3 CPU core VM. There's nothing else like it in the world. The state of the art, by the way, is somewhere in the 30 to 50,000 requests per second on a box much with many more cores and much more RAM than I'm talking about. So I'm incredibly proud of that side of the technology, but that was only one part of it. You need to collect the data at scale. You need to be able to bring in, obviously, all of your inventory data and marry that with this rich time series data set. And you then need to be able to make sense of that data. You need to be able to reason about it. Part of that is through visualization. We need to be able to take these networks, which are inherently graphs of connected devices, routers and switches and so on and so forth, and actually bubble them up to the human operator so that they can understand what's happening in this area of the network, see a living diagram, a living Visio diagram, effectively, of the network at large, overlaid with all that performance data, overlaid with all of your alarm data, understand, change requests that were happening in this area of the network recently, understand the posture of what's going on in this part of the network. We have all the tools available to us. This is actually not an unsolved problem at this point, and certainly Savvy has, forged ahead in making it a solved problem. I just want telcos to actually focus on that, because I think as we add more complexity, if we don't focus on that, we're blindly stumbling into, we want to automate everything, we want to reduce headcount, and you kind of you're forgetting the prerequisites that you have in terms of bringing in data at scale, in terms of making sure that that data is high quality, having the tools to be able to heal that data, to be able to understand what is the quality of that data through the use of things like high performance time series databases, KDB being one such example, graph databases, because these networks are inherently topological, they're inherently things connected to other things. It's amazing to me that graph databases haven't been ubiquitous in telco for many years, because we've had them for many years. And, every year I'm like, this is the year of graph. And every year I'm just a year late. I thought it would be this year, but, maybe COVID has pushed it to next year. So we will see.
And do you feel like it's because people aren't really necessarily bringing the graph together with the time series? Because that's where the real value of it's at the intersect of those two disparate data storage concepts and data processing concepts.
It's because telcos are not innovators, and telcos have largely become meta companies in they push that innovation onto the systems integrators. For the most part, this is not how the Netflixes and co of the world work, right? But it is how we work in telco, and the trouble is the SIs, for some reason, and that is a mystery to me, have not stepped up to provide that innovation. We don't see them. They will push other vendors' solutions, but typically, they're pushing the vendors who've always been here for the last 20 years. Because it's risk-free, right? And because you can deploy them quickly, and it's a known artifact. It has a known surface area of, it's not perfect. Yes, it's expensive, but everybody else uses it.
I guess it's also, we've often followed a real best of breed. So in many cases, it's inheriting what what the carrier already has, and to an extent wants to stay with, and it's just improve around the edges in a way.
I think that's actually hurt us. This notion of best of breed, and up and to the right. And we only select things in that cluster. And those things that are up and to the right, they're decided by analysts who've generally never actually worked in the thick of it in an operations domain. And so we end
up describe a little about up and to the right, so to people who may not understand what that means.
Yeah, so there's various kind of research agencies out there. Should I name them? I don't know. Various agencies out there where they publish, these charts of the vendor space each year, and to be up and to the right is to be the essentially the new hotness. It's the companies that are providing that innovation. It's the companies that are winning the customers. The trouble is you tend to see the same vendors year after year, and it's very suspicious, some of the vendors that you see that are up and to the right and the vendors that are not up and to the right, which makes me think, there's some dollar
We're
amounts
talking 2x2
moving
quadrants
around.
here, for example. So top right corner of a 2x2 quadrant.
Yeah. And it's not decided by industry. This is the thing. It's not decided by people like you and me. It's decided by analysts. And those analysts typically, they might have a good view of, this company's putting out lots of press releases and saying they're doing lots of cool stuff. But they don't have a view as to how it's actually been going in the real world. And I think it stifles innovation because, sure, if you're up and to the right on those diagrams, then you do very well as a business. You are predestined for an IPO and a mighty payday, whether you solve problems in our domain or not. And it comes kind of back to the open source thing and the Netflixes and the Facebooks and the Googles and what they put out, which, they're trailblazing innovation and they share it. Look how much open source software Netflix has released, real critical services that they rely on internally that they open source for the rest of us to build off of. But we don't see that happen in telco very much. I'd like to see a lot more of that. I think we also don't talk about the actual problems we have in the domain enough either. The actual pain points that we have. If we actually do want to reduce headcount, we want to reduce OPEX, which is the kind of current theme at the moment. We want to automate everything. I don't see enough going on in the industry. I don't see enough startups in the industry. I don't see enough grants. I don't see enough investment, which you would see in other industries. But in telco, we just seem to be not very good at that.
It's really interesting, isn't it, actually? So big companies tend to deal with big companies, so therefore the telcos will deal with the big vendors rather than the innovative startups in a way. So it's almost incumbent on the big vendors buying out all those little startups and innovations to then sell to the big telcos.
Given everything that I've said, Savvy was actually very lucky. We started out at Telstra, building out some interesting visions there of where we saw the industry going. We very quickly got to demonstrate that to the NBN here in Australia, and it certainly was a fight. It's a government funded backbone provider. It was a fight to get Savvy over the line ultimately, because you're facing off against all of those incumbent vendors that have been around literally for 20 years or plus 20 plus years. But we did win out from that, and we did go on to build incredibly successful applications inside of NBN, which saved them an absolute fortune, and which still today provide mission critical services internally, for everybody who's using the internet in Australia. And that's a true success story of a small, scrappy startup becoming successful and being taken in by, one of these telcos to do that. The trouble is that, to me, that's not the norm, and it should be the norm. Because, yes, to your point, there is risk in going with a smaller company and not the incumbent, not the company that's, on everybody's lips. But the benefits are enormous. And it's kind of the same benefits that you get with open source, which is that it's you don't have that lock-in. You get to literally contribute to the roadmap, not just moan to your sales, your appointed sales guy constantly. Or we're really hoping to see this. Oh yeah, that will deliver that next year. Or next year comes, it's not there because focus has shifted, right? And of course, a year later in telco, you may as well not have mentioned it. So I think there are some pointed small successes there. I don't mean to, tarnish the industry as a whole and say that there's no innovation going on. Of course there is. I just think that if you compare it to other industries, we're not doing enough in terms of innovation. We're all under threat from... There is innovation happening in telco. Unfortunately, it's not happening from the places that we want it to. It's coming, from the skies. The satellite internet plays, for example. I read a statistic yesterday, and I haven't fact-checked this, so take it with a grain of salt and a small amount of Googling. I believe Elon Musk now controls more than 25% of the satellites in orbit now from his Starlink launches.
And he's only about 1,000 satellites into a 25,000 satellite network, if I understand correctly.
Yeah, just under. Yeah, well, actually, there was an FCC file. I think it is. Yeah, slightly north of 20,000. But and you'll have Jeff Bezos's Kuiper, however you pronounce that one, going up as well. It's going to get very busy up there, and it's and actually this is kind of a good segue, I guess, into the satellite internet OSS space, because you name me an OSS vendor where you could deploy it and hand on heart say, this is going to scale to a planet's worth of customers. Doesn't exist. And that's why companies like SpaceX/Starlink are, forging ahead, building it themselves. Because, if they go and buy anything off the shelf, it's not going to scale. It wasn't built for that.
Well, it's also, I've got an article on the website referring to a doomsday scenario. So the potential for those players to come in and completely disrupt the telco market. At the moment, there are, in my OSS BSS directory, there are 450 plus listings. So that means there's a lot and a highly fragmented OSS market. But if the satellite industry disrupts like it could potentially, we could be talking about only a few OSS needed for a global market. So it's a major disruptor, not just to the telco industry, but also the OSS industry that we work on, rely on, thrive on the projects coming from.
Absolutely. It's a fascinating problem, though, to build an OSS that scales to that level of users. The logistics in terms of managing a global company, even just to get physical satellite equipment out to people, and to manage all of the problems that will come off of the back of that.
Yeah, and yet still the localized regulatory and data sovereignty and all those other issues that they're going to have to deal with. So at scale, but then with localized requirement as well.
Yeah, and the trouble is it cuts into literally all of the pain points that we've had for 20 years in OSS. All of those scaling pain points, well, should have paid more attention to those, because now it's the difference between you surviving and you not surviving. You can't go and re-architect your existing OSS application as a vendor to go from what you've got now, which usually was already struggling, to something that serves billions of people.
Well, not only that, I really look at the legacy of telcos. So, and the variant tree that comes with the legacy, that they've just got so many products to support and so much network to support, so many different variants that our OSS and BSS need to accommodate. Basically, the satellite networks are coming in fresh without all of the legacy. Their variant tree is so much smaller. Therefore, the OSS and BSS are so much less complicated as well.
I've been saying for a long time that, and I think you and I have spoken about this, that I'm surprised we haven't seen the Salesforce.com of the OSS world appear. Because when we talk about OSS, we're all doing the same stuff. They're all the same
often
networks.
Replicating across vendor to vendor to vendor, carrier to carrier. It's highly replicated.
It's all the same stuff. It's all, yes, there's different access technologies, but it's a well understood, footprint at this point. I think if somebody comes along with the Salesforce.com of OSS, and when I say that, I want to be very specific. I'm not just talking about Salesforce as a CRM, as a web-based view of I can go and fill in my customer details and I can look them up and see. Salesforce is a programmable environment. That was how it became so successful, because you could turn it into what you wanted it to be. And in telco, there's so much customization that goes on, from your remedy systems to your assurance systems to your fulfillment systems, and there are all these islands. I mean, culturally, we treat them as islands as well, whereas they are so intrinsically connected together and have to be in order for us to do, closed loop automation, have to be in order for us to be able to fully understand what was the customer experience. What was the journey of this customer, in terms of from the day they signed all the way through to they got the service, and then they had performance problems with the service. There's no reason that can't all be concentrated into one platform, one solution. And we probably couldn't have had it 5 years ago, 10 years ago. The telcos just they didn't have that mindset yet. They weren't embracing cloud. In fact, they were almost anti-cloud, right? They couldn't ever see a day when they would put that incredibly private information, valuable telemetry from the network into the cloud. And now they don't give it a second thought.
And I guess
to their detriment, really. Very expensive to go so gung-ho in the other direction, as many are finding out when they put their terabytes of data into the cloud and then find that, oh, hang on, we keep getting these really huge bills.
Yes. I guess the ramifications too of not having it on a common platform is the integration tax and the number of fallouts, the amount of integration testing, everything else that comes with that. So, yeah, I guess I use the analogy of the WordPress of OSS. Salesforce is probably the better example to use as that common platform to build all tools, integrate all tools.
Yeah, I don't think we should build it on WordPress.
No. I'm talking about
that would definitely be a
single
mistake.
Platform. With,
I'm sure there are some SIs that have tried.
Yes.
Don't get me started.
So we've talked a little bit about your collector technology, and one of the other amazing things that I'm blown away by is Luna, which is one of your visualization technologies. Can you tell us a little bit about how Luna came about, the types of problems you were looking to solve, and I guess just again the benchmarking or the differences with what else is out there on the market currently?
Yeah, sure. We're all familiar with, Google Maps mashups, if people are familiar with that term. Where you've got a Google Maps or a map box or an OpenStreetMaps kind of set of tiles. You can see the streets and landmarks and so forth on a map. And we're all familiar with the extension of that, which is putting markers all over that map, like you might see in any, GIS system. What I wanted to do was a lot of the data that we work with in the telco domain, half of it is topological. Half of it is like a logical Visio diagram where I've got things connected to things. I've got a point of presence, point of interconnect. I've got a bunch of devices in there. They go on to connect to other devices, ultimately to the end users and to your internet providers. But the other half is spatial data. These are real world services. People, ultimately we're connecting to somebody's home, or we're connecting to somebody's phone, we're connecting, shortly to people's connected vehicles. And I thought there was a gap there to visualize that data at scale as well, because I think that's also very important. One of the problems that you, of course, run into with internet services is they are often swayed by the weather or environmentals or, what's going on, again, in the periphery of that particular service. So, for example, if you have a user who has, an internet connection at home and they have an outage, you might do a truck roll to that internet user to solve their problem. But if there's several users on that street who have the same problem, or if on the basis of the cables that, topologically connect them back into the network, they share resources, you really should have the system be able to understand that. And back to my point about, it's not just about the system understanding it, but the operators need to understand what is going on in that area of the network as well. It's kind of a precursor to us being able to reason about going and digging up the roads. It's a precursor to us being able to fault find. I wanted to build a system that could scale to that level of data from a geospatial point of view. And I was very lucky to hire a key person at Savvy who had a background in doing GPU kind of rendering. So the ability to write things that run using the graphics processing unit, the kind of games processor that's in your laptop or system, to push around massive amounts of visualization data. So if you play games, or you've seen obviously these rich fidelity games that people play now just on laptops. You don't even need or on an iPad. You don't need a PS4 or a PS5 these days. Your iPad's incredible at visualizing that. I want to take that same technology and map it into our telco domain and use that to depict everything from the cable traces running in the roads to the environmental data, the weather, the clouds, the rainfall, the lightning, all of these various factors that certainly as we move to towards satellite internet as well become even more of a problem, could be used to depict that. And also to take that inherently time series data set that we had on the server side and which we could reason about across time and push that out to the user of the interface so that they could scrub back and forth in time and they could understand, okay, this user has reported a problem. Is this been a problem just for the last few days? Is this a seasonal, does this have seasonality to it? Does it happen only at a weekend when circuits are busy? Does it happen when there's heavy rainfall in the area? Maybe that's indicative of, an open pit filling with water or corrosion from an external cable. So we built something called Luna, which is this, very advanced geospatial visualization tech that allows us to bring the multiple layers of data together and reason about it across time. So I can understand at this point in time, and I can move back and forth like it's a VCR for your network, whether it be a mobile network, whether we're talking about telematics data from connected vehicles, your engine performance, heavy braking, all that kind of data, whether we're talking about fixed line services, whether we're talking about somebody's handset and you want to be able to use multilateration to see how they were moving through time and look at their customer experience. Oh, as soon as they got on the train and they went along this area, they lost signal. And being able to bring all of these disparate data sets together so that somebody who is, skilled in the domain could look at it and go, okay, I now understand the customer experience that this user has had, that this customer has had. I can bring all of that data together and I can actually work the problem. And that seems to be applicable both to the simple issues of, getting on a train and, I get signal loss. So you need to, put more antennas, more leaky feeders, etc. out there, all the way through to I have connected vehicles, which are going to be, it is going to become more and more important. And, I hesitate to say because of a 5G world, but, hopefully these two inflection points are going to meet together, right? We're going to get connected vehicles and they will make use of the 5G networks. We will need the ability to visualize and understand what the customer's experience was, find those hotspots in the network where we're not serving that customer. There are some tools out there for mobile networks, for example, that allow you to build these heat maps of a customer experiences, a customer's experience, but they're horrible interfaces. So slow, janky, really, the operator does not feel connected to the data at all. Luna, by contrast, is this incredibly fluid user interface where I can go from a map of Australia all the way down to a single household with a mouse wheel, see all of those interconnected data sets all the way through the journey, and reason about what's happening at the macro level, what's happening at the neighborhood, what's happening for this specific user. So that's in a rather large nutshell what Luna is.
I know that you're developing some other technology outside this. You're very inquisitive. You tend to dabble in a number of different areas. So you're already working on some VR products, not specifically for telco, but can they potentially be used for telco use cases? What are some of the possibilities you see with VR, AR mixed up?
Yeah, I really wish that they were applicable to telco. They're not, but perhaps they're interesting in and of themselves. Really it's about, it's inevitable that we are going to see AR glasses, augmented reality glasses, probably from Apple, from, Google, so on. I'm sure there'll be many vendors out there with them. Ultimately, we're going to live in an augmented world where we were wearing these glasses, and over time that will become more and more transparent in terms of, you'll just take for granted that people are wearing these things. They'll be ubiquitous. Everybody will have them. They may ultimately be contact lenses one day, but you will have metadata, you'll have information overlaid on what you already see at the moment in the real world. And I think that's really interesting. Obviously there are telco applications there, and there's been some small successes with things like HoloLens, in terms of, the guy's in the pit and he's able to look either at the road or at the pit once he's dug it up and see which wire in particular he needs to be looking at. Obviously, all of that dependent on a robust physical inventory, which we're not there yet. But again, hopefully those two will meet in the middle, because this is a little bit further out. But on the VR side, which is a completely different domain, I don't think we're all going to be sat there with VR headsets on, not some kind of Matrix style environment, not for the near future anyway. Maybe once we get, full-on haptics and a real kind of visceral sensory feedback inside of these environments. But VR is already extremely compelling. You can go and buy a Quest 2 from Oculus, which is owned by Facebook, sadly, for $400 now, I think it is, and it is incredible. And we could spend a few hours with me recounting some incredible experiences that I have had in VR, and I see this as something that's just going to explode in popularity. And ultimately, dovetail with AR as well, similar kinds of experiences, though different in their own way. So I want to get ahead of the curve, as always, and have been, building out some technologies in that, virtual reality experiences, really. It's interesting because I do see some... So Facebook has I forget what their social platform coming out is, but there's some kind of VR social thing coming out. And... one of to bring it back into the kind of OSS/telco domain, one of the interesting things they're doing, because the Quest VR headset is actually standalone, so there's no PC that you hook it up to. It's completely wireless. It's almost like having a phone inside the VR headset in terms of the processing power there, which is considerable these days, as you know from iPhone and iPad games and such like. So this social experience that they're launching. It's a virtual world, and you can build things in this virtual world. You can build your own experiences, your own rooms, and you can put artifacts in those rooms, and you can build games in it by dragging and dropping 3D objects into this environment. And one of the really expensive things to do computationally when you're building these kind of games, or one of the things that's really heavy on your GPU in your computer, if you're playing a PC game or something, is lighting all of those objects so that they look realistic. Now, of course, on a standalone headset, you don't actually have enough processing power to do a very good job of that at the moment. It gets better year after year, of course. The original iPhone versus what you've got now in your iPhone or Android phone. Sorry to be so focused on Apple users. The processing power that you have, whilst it's impressive, it's just not enough. The amount of processing power just to render a virtual world at 90 frames a second, 120 frames a second in front of two eyes, which have slightly different images to give you that depth perception, is huge. So we just don't have much time left to do this lighting step. So what I thought was really innovative is that, and this is the first time I've seen this done, Facebook actually are pushing that to the cloud. Mm-hmm. So when you drag and drop that object, it looks a little bit shitty. Sorry if this is a PG-13 podcast, but it doesn't look great for the first few seconds, and then suddenly it looks beautifully lit. And what it did was it sent that object data to the cloud and the lighting information, and it rendered it in the cloud and brought it back. Mm. Now, there's a pop-in. It takes a couple of seconds. But when I see all of this talk about 5G and MEC, and, low latency, and you'll be routed to your closest proximal MEC site because, that's the only way we can do connected vehicles that can get feedback, that response loop really tight. And I'm looking for applications of that. That's the first one where I've kind of gone, oh, that makes sense.
Yeah.
Now it makes sense that you're so much closer to that user.
Yeah, particularly in places where they may not have the really high GPU tools at hand. So my understanding is that the telcos in Asia are really investing really, really heavily in gaming server type technology, and being able to support exactly that. So cloud-based gaming or cloud-based rendering of games.
And well, yeah, and certainly as you get to, I mean, we've had, online multiplayer and massively multiplayer games for a long time, and generally they're not peer-to-peer, i.e., if you and I are playing the game, I'm not just sending data directly to you, I'm sending it to a central server that's computing all the physics and sending it to all the other players. So we have this coherent view of the world. Of course, that's very latency sensitive. We've had games for decades that have done that. If you remember back to the original Quake, actually I'm wearing a Quake 3 t-shirt at the moment, as it turns out, which probably ages me. But so when we're talking about maybe, the 20, 30 milliseconds, it's a solved problem. But if we're talking about a virtual reality experience, where I want to really fluidly see, every gesture, especially if we're projecting, faces and muscle movement of, I really want to see the emotions on your face in this virtual environment. We can't do that yet. It's too much data, and we can't get it to you quickly enough for it to really be compelling. We've all seen like Zoom fatigue, and especially over the past year when we've all been video conferencing, and it's especially if you're in different countries, as you often are in telco, right? Because we're all working often with a global team. The latency actually does start to make a difference. We don't have it on this call because we're obviously both in Melbourne, but when you're talking to somebody and there is high latency, you talk over each other. You come off as quite rude, like you stomp on their conversation. You don't mean to, but as soon as that latency gets over about 200, 300 milliseconds, there starts to be this just very subtle. You're not even aware that it's happening. Your brain just can't quite compensate for the increased latency there, and the VR world is similar. If we're trying to play a game of ping pong or something, very difficult if we have high latency between us. If we're wanting to jam online, play instruments together, you really can only do that if you're both, in the same neighborhood connected by fiber at the moment. But I think with the advent of, low latency 5G services, we might be able to push that a little bit further afield. And I can't wait for that. I think I'm not a huge proponent of 5G. I just see it as a natural evolution of everything else that, this march from, God, can I even say the name, GPRS and WAP sites all the way through to 3G, 4G, 5G. I just see it as this natural continuum of evolution of, lowering the latency, increasing the bandwidth, increasing the concurrency. I think things like mech sites perhaps still a solution in search of a problem, but I'm not completely convinced that problem's not going to present itself once we've built out the infrastructure. As we've done many times in telco, we said the same thing, or I said the same thing about 3G when it was launched. Well, actually, maybe not 3G. 3G was a huge departure from what we had before with GPRS and that level of bandwidth. But certainly from 3G to 4G, it was like, really? Is that going to make much of a difference? But it does make a difference. The amount of bandwidth you have on tap with 4G, often it's better than your Wi-Fi connection at home these days. And, I think 5G ultimately will be the same.
Speaking of the march of progress, how is the Apple AR tool coming along?
The Apple AR tool? Are you talking about the glasses that they're
developing? The glasses, yeah.
Yeah, there's rumors, there's supposition. I don't think we truly know yet, but there's a recent patent which does show a head-mounted AR display. There's some funky things in there. Obviously, there's the AirPods and the new AirPods Max, which are the precursors because, they're really doubling down on spatial audio, UHF, ability to to millimeter level understand what is the spatial position of your AirPods and the orientation. I don't know if you've seen, there's a little, it's kind of contrived, but if you have the new AirPods, the AirPods Pro, and you watch a movie on your iPhone, then you can turn on this spatial audio thing. And if you rotate your head, the audio still appears to come from your phone, even though it's being played out through the AirPods in your ears, because it's figuring out the azimuth between the phone and your head, which is a gimmick, to be honest. Because I tried it once and I was like, oh, that's really cool. That's so cool. And then I'm thinking, but if I'm watching a movie, I'm not looking at the screen. So what's the point? But I've been working on spatial audio stuff for the last few years. Well, actually, in some ways, the last several years, as a kind of side project for what's becoming the rapidly growing social audio platform space. And I have some technologies in that area that will be launched fairly soon, which I'm quite excited about. It's funny how everything old is new again, isn't it? The social audio space, look at Clubhouse, for example, is the kind of canonical example at the moment. There's party lines. That's party lines from, what year was that? Was that 80s? That was a long time ago. Isn't it weird that the telcos never managed... How are they bereft of that level of innovation? We were talking 10, 15 years ago about, over-the-top OTT plays. Oh, that's an over-the-top play. This is an over-the-top... what became, ultimately, iMessage and these kind of... and WhatsApp and such like over-the-top plays. Well, give me something that's not an over-the-top play these days. That's the standard. They're not... And yeah, it could have been different. It could have been a different world. Party lines and what we've now got with social audio platforms. The telcos were doing it decades ago. I find that quite funny.
Well, the telco R&D, it amazes me. Go back 40 or 50 years and the things that they were innovating. So microwave and satellites and transistors and optical fibers.
Yeah, the R&D and the investment has never been... It's funny, isn't it? Because we had the ISO, OSI stack, where we had these layers, and at the top of it we had this application layer. And I almost feel that got missed off of many diagrams when people were building telcos. It was like, oh, that's somebody else's thing. Well, that was a mistake, wasn't it? It could have been a very different world. In many ways, I'm glad it isn't, because we've ultimately had this Cambrian explosion of things at layer 7 and layer 8, if we can call it that, in terms of applications as a result. Whereas I think we'd probably just be dealing with MMS, some weird extension of that, and we'd all be incumbent to our operators, and they'd get their lock-in from that, right? So I'm glad we didn't end up in that world.
Yeah, definitely. So what does the future hold for OSS and telco, and how are you positioning for it? I know we've talked about quite a number of things today, and your take on the future, satellite internet, telcos as meta companies, Salesforce of OSS, video streaming. Yeah, what's your take on what the future holds and your position?
I think satellite internet is something that we're all aware of it. And there's a lot of naysayers who say, oh, people have been doing satellite internet for decades, Iridium and so on. But I don't feel that the industry is actually fully prepared for what's coming. I was actually really surprised. The one Achilles heel of satellite internet is I thought weather. And, I was like, it's going to take a while because, of course, satellite internet's it can be affected by environmental factors. So, lightning, clouds, etc. And your internet goes down. That's not very good. So it's going to be, a decade before any of that is fixed. And then I saw in the recent Starlink tests, there was a beta tester who, he did a YouTube video and it was horrendous weather. And he was doing a speed test on it and it was great. And I was like, oh my God. So I think satellite internet's going to come out of nowhere and really hurt the traditional telco industry. It will survive, of course, for a good long time. But it's going to be licking its wounds, I think. And it's going to find it difficult to prevail and not to be that race to zero in terms of revenue. Already they're trying to reduce headcount and OPEX and obviously CapEx builds as well. So scary time to be a fixed line operator. Mobile, more interesting. 5G's kind of reignited the passions and the innovation somewhat. So that's good. In terms of OSS, as I mentioned before, I think any existing OSS vendor out there, well, good luck scaling to what's coming. I'm perpetually just dismayed by the innovation in the OSS space. Sadly, it just doesn't happen. Obviously, I've been working. I'm slightly biased because obviously I've been working on innovation for quite a while in OSS, but it's not obviously gotten out to the world at large. It's not used en masse around the world just yet. Maybe those days will come, but we really need to start building greenfield OSS systems that can accommodate the scale of services that are coming.
Well, an interesting portent is the standing down as CEO of Jeff Bezos and the focus in on his satellite internet company.
Yes, although he has a lot of other things that he wants to get done, right? I suspect that the satellite internet thing is just a billionaire's playground, right? Elon Musk is actually very serious about it because it underpins everything that he wants to do to get us to Mars ultimately. And Starlink is, I think a potentially good way of financing that. The numbers seem to work out amazingly well if he and you wouldn't bet against him, right? Whereas I'm not convinced for Jeff Bezos that it's a real focus. I suspect he's going to go more towards the philanthropic side of things. No problem with that at all, of course.
Given that you're always on the bleeding edge or well over it, are there any other changes looming that us mere mortals might not be aware of yet?
Changes looming. I think we've covered a lot of them, right? Across VR, AR, 5G, mech, connected vehicles. I think we're going to be living in a world awash with even more data than we had before, which is scary to contemplate. Don't know where we're all going to put it. Hopefully not on AWS, or we'll be bankrupt. We need to make use of that data. We've historically had a problem in particularly in the telco domain in collecting and making use of that data. I hope that that's going to start changing. I think that will cause us to get better at managing these ever more complex networks, especially as we add all of these virtualization layers and these dynamic services on top of that. Other than that, yes, I could talk for hours about future navel gazing and things that are coming.
So the data collection, that's a great segue into the next question too, is your go-to learning resources. I know you consume a lot of information from a lot of different resources. You're able to articulate what some of your favorite sources are and how you go about aggregating them and making sense of them.
It's a blessing and a curse. I wouldn't necessarily want to teach somebody else how to do it, actually. I've become very good at mining massive amounts of feeds of information. I still cling to the old RSS feeds, which is this, if for those not familiar, is this protocol where, you don't have to visit the website. You can have your app go to that website and pull the information in and consolidate it with all of your other feeds of information. So I'm still a heavy user of that.
How many RSS feeds are you tracking?
Oh my God, I think it's 270 something. It's ridiculous. Some of them are, don't post every day, but a lot of them do. I also voraciously curate and consume Twitter, very carefully in terms of who I follow and different lists of followers. Twitter's an incredible resource for that kind of thing. A lot of people see it as this echo chamber of just people chatting to each other, but it's far more than that. I've had such valuable feeds as well as conversations from people on Twitter as well. So that's also a very useful source of information. But as I mentioned, it's a blessing and a curse. I've become very good at scanning massive amounts of articles and extracting the valuable nuggets from them. But I can't read a novel these days. I find it very difficult to pick up, any kind of, whether fiction or non-fiction. It's really difficult to force myself back into reading a paperback something, even if it's for work, even if it's, learning a new programming language or something, which I've always learned by just doing, having a project.
Yeah, having a use case to go and build or solve for. I tend to tackle things the same way.
And some of those use cases have turned into, successful products, both at Savvy and beyond as well. It's so I definitely think that the best way to learn something is to just jump in at the deep end and just start building, because
find something
just
worth
through
building for or solving.
Just by having the passion that you want to build that thing, you'll get there. It might take you longer, but there's nothing more rewarding than creating something from nothing. And I mean, that's why ultimately we choose to become entrepreneurs, why we choose to become software developers, engineers building infrastructure. That's why we do it all, right? To create something that didn't exist before, and to solve problems that we perceive as valuable, and hopefully which are valuable.
Yeah, so we're coming towards the end. Are there any pearls of wisdom for those starting out that you'd like to put out there? I know we've covered a lot of insights, but any pearls of wisdom?
Just always be curious. The world is just full of, there's so many interesting things going on. I'm guilty of having far too many hobbies and time slicing myself across all of these myriad different ventures and interests, and but it's incredibly exciting and fun, and that cross-pollination of ideas from these different domains just gives you this incredible ability to see what's coming, well ahead of the curve, and if you start building those things, then that creating something from nothing is great, but creating something that is valuable to somebody else, there's nothing else like that feeling. That's an incredible skill to be able to harness, and I wish more people would get passionate like you are about OSS. And I don't know how you get through the workload that you have, and being able to write all of the articles that you do, and podcasts on top now, and as well as day jobs and consulting and all of that. I wish others could find that passion. Just pick a problem domain. Pick a problem. Don't leave it unsolved. Go and solve it. You can solve it. You don't need to be a programmer. You can find programmers. You don't need to be an engineer. You can find engineers. Just take it on as your passion project and make something that didn't exist before.
Yeah, brilliant insight. And I guess there are so many opportunities that you must spot. Do you have a way of kind of filtering the ones that will be valuable? How do you go and stress test or pressure test some of those ideas and see, is it just something that you would find really interesting and valuable, or how will it actually go and change the world?
Some people do that, and they're probably better for it. I generally, sometimes you can't ask anybody. As Steve Jobs said, and I'll probably screw up the quote. If you'd have asked people what they wanted, they would have said a faster horse.
Yeah,
it was Henry Ford, right?
Yeah.
Or he requoted it, right? And it's absolutely true. So a lot of people, and it's actually been quite astounding to me, is that a lot of people actually can't see ahead of what is now. And I think I wish those people would, could force themselves. Perhaps it is an ability that they do have, but just have never explored. Because I don't believe that it's something special or unique that only some people have access to. But that ability to be able to project from where you are now to what's coming, I think is really valuable.
But I also find you're really, really good at thinking through the challenge and reasoning about why something, the pros and cons, I guess, of going ahead with a solution. Particularly, I've seen you do it for your own products, but also for just other people coming up with ideas. Like we talked about it in the intro, some of my hair brand schemes, you're able to really break apart.
I'm a great devil's advocate.
Yeah.
Sometimes naysayer, but not always. I genuinely can. I can sit on both sides. Sometimes I'll play the positive and the negative, because sometimes you just need to provoke that reaction in the person who's thinking about it. You just need to make them think about the negative side of it, because they haven't thought about, what about this? What about that? Why? This is why it wouldn't work. And they need to engage in that discourse and combat against that, so that they can refine that idea they have. to something. There's a lot. It's very easy to get stuck in this microcosmic view of, what I've come up with is the most perfect solution, and nobody could ever, say anything else. Then you go and build it, and it turns out, you were completely wrong. You forgot about all these aspects, and there's this other product over here that does 80% of it. There's lots of facets to building new products and solving solutions. So it's always good to get that litmus test across people like me, and I bounce ideas off you as often as you bounce them off me. And that it's that feedback loop that you need. And sometimes, when you come to me with, an idea, I will take the other side of it, not because I genuinely believe that. Sometimes I actually fully believe in the idea, but I want you to explore that side of it, because you know that domain in many cases better than I do. But sometimes we need that provocation. So it's useful to have friends around you who have that ability to open you up to think about things from different points of view. I find that incredibly useful from a product management, navel gazing product design point of view.
Yeah, really good point again, and that's actually part of the reason for the podcast, and the reason I'm not just looking at this as an architectural piece, but to bring in salespeople, marketing people, the C-suite, how all these different people interact with the OSS, how they see it, how they are looking to take it forward, take the industry forward. So, yeah, really good insight.
It would be fascinating, some of the points I've raised today, and I'm not saying that, I'm an oracle of knowledge in this domain. I'm certainly not. I would be fascinated by, C-level, by incumbent vendors, other innovators coming onto this podcast and rebutting against what I've said today, and saying, you said we're, bereft of innovation, but what about this? What about that? I don't think we do enough of that in the industry. We're very, the information we put out, it's all very positive. We're not actually engaging in the discourse that I would hope that we would. And I think through that we could actually solve a lot of problems that have been literally here since the very beginnings of telecoms and IP networks. So hopefully this will be one of those platforms, if not the platform, that spearheads that.
Fingers crossed, hey? So I really, really appreciated your time today, Jay. Where can people find you?
Oh, I'm on the internet.
That's only a small Google place. Away. You should be able to find that really easily.
I was very lucky to register the dot or na.nu domain name many moons ago now. God, I must have had that for 20-25 years, that domain. So my personal email address is na.nu, which is an homage to Mork and Mindy, Robin Williams. Yeah. I once wrote to him and offered him an email address on there, but clearly he wasn't interested. I know he was an avid gamer, actually, so I thought he would have liked a Nanu email address, but maybe that ship had sailed at that point for him. All
right. Thanks again, Jay, and thanks also to the audience for listening in to the latest episode. We'll bring another one to you shortly.
Thanks very much, Ryan.
Thanks for listening to the Passionate About OSS podcast. You can find more episodes, more than 2,500 blogs, and our contact details over at passionateaboutoss.com.